Hi friends, welcome. We're going to be taking a look at an algebra topic today, something that we want to review because we're going to be needing this skill in some future topics in geometry. Specifically, the skill I'm talking about is solving systems. Now, you may remember solving systems using a couple of different techniques, namely one technique called elimination or combination, and then a different technique called substitution. For today, we're going to be concentrating more on the elimination or combination, depending on how you were taught, version of solving the system. So if you take a look at the very first example with me, we can see that we have two equations of lines. And our goal here in terms of solving a system, recall with me, is the idea of finding a point that they have in common. So we're looking for where these two lines intersect each other, and so therefore that intersection point is a point that they both have in common. First thing we want to do is set ourselves up for a way that when we combine the two lines together, that one of our two variables actually combines to be 0, and therefore allows us to solve for the remaining variable. So when I look at these two equations, I'm noticing the first one, I have this 3x, and in the bottom equation, there's a negative x. I mean, it would be lovely if this could be a negative 3x, right? When we combine it with the 3x up above, those would add to 0. So that's fine. We can make that change so long as if we decide to multiply it by a 3, that we multiply every piece of that equation by a 3. That way, we're not messing up the actual equation itself. Whatever we do to one side, as long as we do it to the other, we'll maintain the equality. So my new system is now going to look like, well, I didn't do anything to the top one, so I'm just going to rewrite it. Now the bottom one's going to say negative 3x plus 9y equals 18. And now I'm set up to combine them. Now, some people call this elimination because of this move right here. When we add the 3x and the negative 3x, those combine to be 0x. So they're eliminated. We're left with 15y equaling 30. And now I can easily solve for y. Divide both sides by 15, and y will equal 2. Now we're only partway there because we all know that an ordered pair, an intersection point, is a coordinate and therefore has both an x and a y value. So we need to grab the x value. You can use whichever equation you want to from the beginning of the problem, whichever of these you'd like to, and we can substitute a 2 in for y and then solve for x. So it's really your choice what you want to do. I guess I'll go ahead and just choose the top one, throw a 2 in for y, and this allows me to solve for x. Subtract 12, and I'm getting 3x equals 0. So when I divide both sides by 3, I still have 0, which is fine. That just means that this ordered pair is at 0, 2. Those are my x and y values, and that is also the point of intersection. So you have a few more problems that you get to practice with here today. You may notice that some of these may require you to adjust both of the equations in order for elimination to occur. So the first thing I notice about part B, just to kind of get everyone started, is that my x's and y's aren't even lining up yet. So you have this standard form of 2x plus 4y equals 10. I would really like this second equation to be in that same format. So I would like to move this 3x over to the other side. So I'm going to go ahead and make that a negative 3x. The 5y was already there. and I left the 18 on the right. Now things are lining up, and visually, I just think this makes things a little easier to figure out what you'd like to do for elimination. So again, I am noticing I have both a positive and a negative. So one way to approach this problem would be to make both of these be 6 for the coefficient and then opposite of 6, so that these will add to 0. So we can multiply the top by 3, the bottom by 2, and then I would have a 6x up top, a negative 6x in the bottom, and elimination should work for us. It doesn't mean you can't use the y's. You can. Like, I'm looking at this thinking maybe my great elimination would be if these y's had, a 20 as the coefficient, one being positive, one being negative. So let's think about that. That would require me to multiply everything by, let's say, a 5. So that would give me the 20y. But then I would need to multiply the bottom one technically by a negative 4 to get the negative 20. And that's an option as well. So you can choose how you'd like to do that to go through the problem. I just thought I would point out that sometimes you have to adjust both equations. When you're finished trying these problems and practicing, the answer key of this worksheet is available on Canvas for you to check your work. There is also another way that you can check your work, and that's by using a calculator. So I'm going to go back up to problem letter A and show you a way that we can check our answer. And this is actually on any sort of a digital calculating device. So both, you have your handheld calculators. You also may have a calculator app on your iPad, and or you can always access Desmos through both an app or just your web browser. And all of these are great options for checking your work. If you're using a TI-84, for example, handheld calculator or the app on your iPad, you will have to write your equations in a y= form. So what that means is you want to take your equations and, for example, the top one looks like this right now. I need to solve for y because that's how we can type it into our calculator. So if I move over the 3x and then I divide everything by 6, I'm seeing that this is y = -1/2 x plus 2. This will be the equation that I'm going to type into my calculator. I'm going to go ahead and just highlight that so we can come back to this in a minute. There's that. And then let's go ahead and write the other equation. So I'm going to work over here. The other equation, -x plus 3y = 6. I'm going to go ahead and move the x over. I'm going to divide everything by 3. And I'm looking at y = 1/3 x plus 2. So there's my other equation in y = form for my calculator. So if we go to our calculator app, so mine is located right in the middle, Calculate 84, or your handheld device, you can see I've already typed in the equations. Okay, both equations are already typed in, -1/2 x plus 2, 1/3 x plus 2. And when I hit graph, I can see my equations that the two lines have been graphed. So if I'd like to truly identify the intersection point, we can hit second and then the trace button, which says calculate. And the fifth option is intersect. And what we can do is just go ahead and you can see, you can move your cursor a little bit and hit enter and move over, enter, just to kind of ask the calculator to look in between these boundaries. And we should get our intersection point. Second, calculate, intersect. sorry, let's go left bound, right bound. Oh, there it is. And our intersection is right at the top at 0, 2. I don't know that I can actually highlight that to see it, but if you look at the bottom of the graphing screen, it says intersection, x equals 0, y equals 2. So you can get that intersection point. Another way you can do this is by actually going to Desmos. So if we go to Desmos, the nice thing about Desmos is that you don't have to solve for y. You can really just type in 3x plus 6y equals 12. And then our other equation was negative x plus 3y equals 6. And now we can look for that intersection point again. And if you just tap where it's intersecting, boom, it tells you on the screen what that ordered pair is, 0, 2. So a couple of different ways that you can check your work. You can use these iPad apps. You can use your handheld graphing calculator and verify the answer that you are getting using your algebra skills. Feel free to go back and rewatch any parts of this video to help you understand solving a system, and then go ahead and move forward with trying B, C, and D. Again, answers are located in Canvas. And also keep in mind that if you want a little more practice, this QR code will take you to some practice located in IXL. Use the codes that are given, and it should take you to some systems. Have a great rest of your day. We look forward to seeing you soon. Bye.